Can you hear me? Okay, thank you. So, okay, the audio is okay. Can you see the slide? Okay. Today we will continue with the simulation examples in the spreadsheet. All right. So last week we took a very simple example of a single channel queue system. Okay, and we use a simulation table where we try to simulate the randomness of the arrival of the customer and the service time, and then we monitor the statistics like the waiting time of the customer, the number of the customer in queue, or the idle time of the server, right? So this is what we and the last time. So in order to simulate the arrival time of the customer or the service time for each customer, we use a random number technique. Right? You still remember that one? It's like this one. Okay. For example, let's say we want to simulate an event with a certain probability, then we will use the random number, which the probability of occurrence of that number is the same with the probability that we want to simulate. Okay. Let's say the service time, for example. We want to simulate the service time vary from 1 to 6 minutes. Okay. So, and we have the probability for each service time, 10%, 20%, and so on. So we can use one random digit from 0 to 99 and assign the range for each service time. Like if we get any random digit falling from 1 to 10, then we will assign the service time 1 minute, because we know that the probability that we can get any number from 1 to 10 out of 100 random number is 10%, exactly the probability that we want. So do you recall what we have studied last week? Okay, so the next example is a little bit more complicated of a queuing system. So instead of a single channel queue, we looked at a queue which have two servers. Okay. So here in this system, this is the queue discipline. We have one queue and two servers. Okay. We call them able and beggar. Okay. So let's say this happened in a driving restaurant like McDonald's, for example, where we have a driving system. So the car arrives, and then we have the car hosts named Able and Baker, and they will bring the food to the car driver. Okay. So here, what is random? We also have the car arrive in the random manner. Okay. And we also have the service time of each server, Able and Baker, also random. Okay. So we may come up with a general rule like if both of them are free, both Baker and Abel are free, then we will assign the driver the car to Abel because according to our data, Abel is a little bit faster than Baker. Okay, but if both of them are busy, then of course the customer will begin the service with the first sufferer who is free first. Okay, all right, so that is our simple rule. So very similar to our previous examples, we also have the data related to time between arrival of the car in this table. Okay, so the time between arrival of the cars is vary from 1 to 4 minutes with this probability. Okay, and this is the service distribution of able vary from 2 to 5 minutes with this probability. And we have the service distribution of breaker in this table. Okay, now let's say if you still remember what we have learned last time, let's look at the time between arrival, table 2.11. Look at this table. If we want to simulate the time between arrivals in this table, can you tell me how I should assign the random digit? Yeah. Anyone can give me your suggestion? How should I assign the random digit to simulate the probability of the time between arrivals in this table? Let me invite someone. I have one volunteer here. So can I see the answer? I just saw some answer. Okay, so I have the answer here. We will assign 1 to 25. 1 to 25 for time between arrival, 1 minute. That's right, Hugh. How about, okay, and 26 to 65 for the time between arrival, 2 minutes, 40%. That's right, excellent. Okay, can you continue with the time between arrival, 3 minutes? So you copy the answer here. So the first one would be, let's let it get, 1 to 25. The second one would be 26 to 65. Okay. All right. So you can get the hint here. You can look at the cumulative probability. All right. For the final digit of the range. So the 20% would be from 66 to, like what you say, 85 exactly. And the last one would be 86 to 00. Okay, thanks, Min. Thanks, Hiếu. All right, so you get it. Okay, so the rest, I think that we no need to go into details in this table. Like we will have a table where we will monitor the arrival time. Okay, we will generate the random digit for the arrival, random digit for the service, and then we will get the time between arrival and the service time. Okay, and we slowly can monitor the service of Abel and Baker and the time that the customer in the queue. Okay, so in this example, we will do the simulation in 60 minutes. Remember in the previous example, we do the simulation for 20 customers. Okay, there are two ways to decide the length of the simulation. Either you can decide by the time how long you want to run the simulation, like 60 minutes in this example, or like how many customers you want to simulate. Okay, so in this example, we will choose to simulate for 60 minutes by observing the simulation clock. Okay, so we will take note the time each customer arrive, and we will stop about minute 60 or 59 because sometimes we cannot get exactly a 60. So around that one. Okay, and we want to answer after the simulation, like how busy is Able as compared to Baker. So how do we answer that questions? We may look at the total time that Able in the service and the total time that Baker in the service. Okay, and we also want to know whether the customer have to wait for long. Okay, by look at the time in queue of the customer here. Okay, of course, we have to take the average. Okay, and then we will answer should we add more server. We use 3 servers instead of 2 or not, or 1 is just enough. Okay, so for this one, I would like you to try at home with Excel because it's quite tiresome when we do manually, but we totally can do this in Excel. And the next few slides give you a very detailed instruction on how to do it in Excel. Okay, so in Excel, the way we generate the random digit is to use the function, the built-in function in Excel. Okay, you don't need to use the calculator, but just use this function random. Okay, to generate the random digit, and you will have your room to assign the random digit with the inter-arrival time, the service time. Okay, so you need to spend time and make effort for the first 2 customers, and after that you grab it and you will finish this very fast. Okay, so I leave this one for you to do at home. Okay, now let us go to another example, which is also very interesting, inventory system. Okay, so now this picture illustrates a very simple inventory system. So I believe that you already have a basic knowledge of inventory system when you took the course production management, right? Okay. Or if you study logistic program, you have a special course dedicated for this one, inventory management. So let me give you a recall of how it works. Okay, so let's say what happened in the inventory system. We have inventory and we need to manage our inventory so that we always satisfy the customer demand, right? And in order to meet that objective, we have to monitor our inventory level. Okay. So if our inventory level too low, we have to make order to the supplier. So we need to make decision like how frequent we need to make order to the supplier. Or in other words, how should we monitor our inventory? Should we check it every day or every week? And then when we should order the supplier, and when we order, how much we should order, right? Okay, this is very common sense. So let's say, look at this figure. This figure illustrates our inventory level over time, and it changes according to the demand of the customer and how we make an order to the supplier. Okay, so okay, the x-axis, this is the time, okay, and the y-axis is our inventory level in our store. This is inventory level in our store. Okay, so at the beginning, our inventory level is somewhere here. Okay, and then it drops over time. Why it drops? Because we have to sell. Okay, let's say there's customer demand, so we sell our product, so our inventory level drop. Okay, and here we assume that the demand is a constant rate, right? We assume that one. Okay, so we have a straight line here, so it drops in a linear function because the demand rate is linear. That's what we assume. Okay, now in this picture, we assume that we will review our inventory level every n days. Every n days. So, all right. It's good to monitor our inventory level continuously, but in some system it's impossible because we have many things to do. Okay, so we cannot keep simply continuous. We continuously monitor the inventory level. So let's make our policy here. We will review our inventory level every n days. So every n day here, we look at the stock level, and then we decide to place an order. And the other quantity in this example will depend on our storage capacity. Okay, so let's say in this example, we like to place an order to the maximum of our storage capacity. Okay, so let's say our store can only store 100 boxes. So we will order up to 100 boxes. All right. So the maximum inventory level, the maximum storage here, I put as the name. Okay. So we place an order to the maximum of our storage capacity M. And when we place an order, our inventory level will increase to M. Do you see any assumption here? When we place an order and the inventory immediately increase to M. What is an assumption here? Usually, when we place an order, will we receive the stock immediately or not? Yeah, excellent firm. Here we assume the lead time 0. Okay, when we place an order, we immediately receive it. So our inventory level immediately increase to M. But let's say if there's a lead time, for example, then our figure should look something like this. Okay, we try to plot another figure here. Okay, so our inventory level go down. Okay, and okay, so this is our our review period, and then we place an order here, and we still have to waiting. Okay, so while we still waiting for the stock arrive, our inventory level keep go down. Okay, so until after certain lead time, we receive the stock from the supplier, then the inventory level will increase. So there will be a lead time between when we place an order until when we receive the stock and our inventory level increase. Okay, but here in this figure, we assume this lead time equal to 0. So we place an order here and we immediately receive the inventory. Okay, very good. All right, so similarly, after that, our inventory go down because we selling to the customer, and then after n days we review and place an order, so it increase again. So even though we assume that the demand rate of the customer is constant for every period, but it will vary for different periods. Okay, so in these periods, this is the demand rate, but in the next period, the demand rate is steeper. Okay, so it means that we have more customer demand, so it's steeper. Okay, so anyone can tell me what happened at this point? What happened here? The blue circle, the blue one here, a circle. What happened there? Right, we have shortage. Okay, we have back order for the shortage. Okay, we see. We wait after n day. We wait until after n days to review. But the shortage happened before n days, and we are not aware of that. Okay, so we cannot make action promptly, and the shortage happened before we place an order. It is somewhere here. Okay, so the shortage happened here before the day that we review. So we have to suffer that condition until the day we recognize this when we review our stock and then we place an order. So what is random in this inventory system, everyone? What is random in the inventory system that we have to consider? Demand is random, right? Right. So when we simulate an inventory system, we have to simulate the demand, okay, the random demand. Okay. What else may be random here? Just now we assume that lead time is 0, but let's say if lead time is not 0, is lead time also a random variable? Do you think so? Yeah. Okay. So most of the time, the lead time that the supplier tell us also vary. Okay, they say 2 days, but sometimes it may be faster, sometimes it is longer. So lead time is also random. So in an inventory system, we have to pay attention to the demand and the lead time, which is random. Okay, and now that's for the input. Now, what may we be interested in? knowing in this system. Okay, what do we want to identify in an inventory system? Okay, just now I told you that we need to determine the review period, right? And let's say the how much we need to order. All right, so we don't want this situation occurring, the shortage, the bad order happening. Okay, we don't want to lose customer. So if we want to avoid shortage, what can we do? If we want to avoid shortage, what can we do? We have to keep stock, right? So we try to keep more, right, higher inventory level. Okay. Now, what else? Create safety stock, right? Carrying stock, that's right. That is about M. Okay, so try to keep M as high as much possible. Okay, forecast demand, that's right. Now, how about the review length? The review period. What can we do with the review period? Should we shorten or should we lengthen the review period? I guess you say shorten N, right? N is for the review period. Yeah, so we have to review our stock more frequently. Okay, so reduce N and right increase M. But what is the disadvantage? Okay, what is the disadvantage if we stock too much or we review too frequently? What is the disadvantage? Costly, that's right. So cost, where's the cost come from? High cost, yes. Where does the cost come from? Owning cost, right? So we have to have a very large storage to store our inventory, okay? And and for the holding cost, it's not only about the money that we pay to hold the inventory, but you also can think of the opportunity cost. Like we don't have much cash, and then we have to buy a lot to stock. Let's say if we know just if we just buy just nice quantity, and the quantity we keep just nice, then we can save money to invest in other things. Okay, so the cost, the holding cost may be in the money we pay for the storage, but it's also in the form that the money that we can invest somewhere else instead of buying the stock. Okay, and besides the holding cost, we also have what happens if we make orders so frequently. We also have ordering costs, right? So well, there are two ways to keep higher stock. One is we place an order, and one order we make a very large quantity, or we review continuously and make order frequently. But when we make the order frequently, we also have to suffer ordering costs. Okay. So in inventory management, we have balance between the cost, like the holding cost, the ordering cost, and then satisfy the customer demand. And and in the context that the demand of the customer is random and the lead time is random, right? So we will simulate an inventory system and try to answer what is a good policy that we should follow for a given data history that we collect. Okay, so the inventory policy we refer here is the period review. Okay, how many days we should review, and let's say we also determine what is the maximum stock and we need to keep. All right, so that is the purpose. Okay, now, as I told you previously, simulation doesn't give us an answer. So we have to test the solution ourselves. So in this example, the simulation doesn't give us what is the optimum M and N we should follow. But we have to try. So let's say we would try with this policy where we set M, the maximum level is 11 units and the review period is 5 days. So this is what we want to try to see what happened with this policy, and this is what we have from the demand and the lead time of the suppliers. So the demand, according to our history data, it may vary from 0, nothing, 1 day there's no customer, 0, to 4 units. Okay, 0, 1, 2, 3, 4. We assume that this is what we get from our historical data, and we will simulate this historical data. Okay, and again, we also come up with the probability from the data. 10% of the case that we receive no demand, no order. 25% we receive one order per day, that day. 35% we receive 2 orders on the day, 21% 3 days, and 9% that we got 4 orders on that day. Okay. So we use the same technique, all right, assigning the random digit for the demand and the probability. Okay, so you can think with me, 10% here, I can use from 1 to 10 out 100 digits from 0 to 99. So for this one, I can assign from 11 to 35. So this one will be around 25%. All right, 11 to 35, I will got 25 number. Okay, so correct me if I made any mistake here. And 35%, I would assign from 36 to 70. Okay, so there are 35 numbers from 36 to 70, so it would be 35%. 21% should be 71 to 91, and the last one would be from 92 to 00. Okay, so you can do similarly for the lead time. The lead time varies from 1 to 3 days with this probability. Okay, let us come up with the simulation table. Okay, so here our review period is 5 days, so we will have a review cycle 5 days. So you look at here, 5 days, and we will simulate this inventory system for 5 cycles. Each cycle is 5 days. Okay, 5 days. So we need to simulate the demand. Okay. and the lead time when you place an order. So the lead time is here. Okay, demand, the random for demand here. Okay, so let's say we want to test whether this policy is good or not by looking at the average inventory in our system. You can convert the average inventory into money if you want. Okay, but in general, the higher inventory, the high inventory that we keep in our system is not good. Okay, because we have to suffer holding costs. So we have to look at the average inventory in our store, as well as whether we observe any shortage along the period or not. Okay, so we will monitor the inventory level and the shortage. We want to see with that inventory, is there any shortage happen or not? So if we keep very high inventory, if our average inventory is very high and there's no shortage, so perhaps we may try to reduce the maximum inventory level, or we try to lengthen a little bit the review period. Okay, because we say that, well, we keep inventory too high, all right, and we are still safe, so we will try to reduce that one. And let's say if our inventory is low and we see shortage occurs, then we may adjust the M in the end again. Okay. Again, we don't know what is good one, so we have to test. We have to try. That's the disadvantage of simulation. Okay, so let's try. All right, so we're starting with day one. Okay, we're starting with day one here. Okay, we assume that our beginning inventory is 3. Okay, we can assume a number here. Okay, and we will generate a random digit for demand. We got 24. So 24, if we use the table, it will corresponding to 1 unit of demand, one unit. Okay, so on that day, our ending inventory would be 3 minus 1. We have 3, we sell 1, so we left with 2. This is our ending inventory of day 1. There's no shortage occur. Right. We have sufficient inventory. All right. And let's say we assume that before this day, we already placed an order from the supplier. Okay, and we are waiting for that order. Okay, and we assume that the days that that order arrive is 1 day, so we are waiting 1 day to receive that order. Okay, now continue with day 2. Our beginning inventory of day 2 would be 2 is the ending inventory of day 1. Okay, so it would be 2 here. Okay, and the demand for day 2, we generate a random digit. We got 35. So the demand again is 1 unit, and the ending inventory of day 2 is 2 minus 1, it is 1. Okay, no shortage occur, and on day 2, we receive our order. It becomes 0 here. Okay, so on day 3, we are on day 3. What is our beginning inventory? Okay, our ending inventory of day 2 is 1. This one here. Okay, and day 3 is also the day we receive the order from the supplier. Okay, And we assume that we place an order of 8 units of the previous cycle. So the stock will increase from 1 plus 8 is 9. Okay. And on day 3, the demand, we generate random demand, we got 2. So ending inventory of day 3 is 7. 9 minus 2 is 7. Okay, no shortage, and so on. Okay, we try to finish one cycle. Okay. All right, day 4, beginning inventory of day 4 would be ending inventory of day 3, which is 7. Okay, demand for day 4 is 3, corresponding to 81. So ending inventory of day 4 will be 7 minus 3 is 4. Okay, doesn't happen on that one. Now let's try day 5 of cycle 1. Day 5, our beginning inventory is 4, is the ending inventory of day 4. Okay, and the demand is 2. So our ending inventory would be 4 minus 2 is 2. Alright, so day 5 is also our review day. So if our ending inventory is 2, then how many we should place order to the supplier? What is our order quantity? Our policy here, we want to try a policy with n equal to 11. Okay, so we will place an order to the maximum 11 units. Right, so our ending inventory is 2. So we will place 9 more, and that will make our stock to 11. Okay, so we place 9. Okay, and we have to wait. So we generate a random digit for lead time. We got 5. Number 5 corresponding to the lead time 1 day. So we have to wait 1 day to receive the 9 units. Okay, so we will continue like that for other cycles. Okay, so let's try one example where we observe the shortage. Let's look at cycle 3. Okay, cycle 3, day 1 of cycle 3. Day 1 of cycle 3, our beginning inventory is 2. Our demand is 2. So the ending inventory is 0. Okay, and we still have wait for 2 days. Alright, to receive the order. Okay, this is very dangerous situation. We have no inventory and the order still not arrived. So day 2 in cycle 3, our beginning inventory is 0 and there's a demand on this day 2 units. Okay, so our ending inventory is still 0. We have nothing. But the shortage happening here. We shortage of 2. And we still have to wait 1 more day to receive the order. Okay. Day 3, we still have 0 inventory. And there's another demand arrive. We receive another 2. Okay, so our ending inventory is still 0 and now the stock shortage increase. 2 plus 2 is 4. We have 4 unit shortage. And okay, the next day we will receive our order on day 4. So on day 4 we receive 9 units from the previous order. Okay, the order already arrived, so we have 9 units. The demand on that day is 1. Okay, but we have to minus another 4 units, we assume that the customer are willing to wait for us. So we don't lose the customer, so we are able to sell this one and another 4 in the previous days. So our stock will left with 9 minus 1 and 4 is 4. Okay, so it depends on the rule we want to set here. So at the end, you can compute the ending inventory. After 5 cycles, you can calculate the average of this one, and we observe 2 stoppage here. It happen on day 2 and day 3 in cycle 3. Alright, so this is the quick calculation. The average ending inventory from that table is about 3.5 units. And on 25 days that we simulate, we observe a shortage condition. So what is your suggestion? Okay, so well, we have no answer. So you want to avoid shortage, so maybe you want to try to reduce 5 days to 4 days or 3 days to see if you can improve the situation or not. Okay, or we can, if we are constrained by M, we cannot increase M, then we fix M. But let's say if you can increase M, then you can try to increase M to see if you can come up with a better solution. Okay, so this is a very simple example of inventory. Now, you also can try this one with another popular inventory problem we call newspaper sellers problem. So, have you learned about the newspaper sellers problem? Have you learned it somewhere? Okay. Okay, we talk about selling of newspapers. So what is the characteristic of selling newspaper? What may be the problem? It's still inventory management, so you still have to decide like how many newspapers you should buy. It's like your newspaper is your inventory. But what is the characteristic of this inventory? What is the characteristic of newspaper? The newspaper is perishable, that's right. Okay, so you can compare the newspaper with perishable product. It means that after a certain period, you cannot sell it anymore. Okay, now, we will consider another random factor here. That is the demand will vary with different days. Depends on the quality of the news on that day. Okay, so we here in this example, we assume that there are 3 types of news day, and it can be good. Okay, something there is very interesting news on that particular day, and so the selling is very high. On the news day may be fair, okay, normal or very poor. So the probability of the types of new day we follow this one. Okay, and depends on the news day, then we have the probability of selling our newspaper. So it's come up like this one. So this is the data we have. Right, so you look at this table. This is type of news day. We have good news day, fair news day, and poor news day with this probability. If you plus all of them, you will have 100% here. Now, Let's say if this is a good day, we look at the demand on good day. This is the demand on good day. If it is a good day, the demand is also vary. It's not constant. Okay, so we find that 3% that we can sell 40 papers, 5% that we sell 50 paper, 15% we can sell 60 paper, and so on. So the sum of this one would be 100. The demand, the selling can vary from 40, 50, 60, 70, 80, 90 to 100. This is the demand probability distribution when it is a fair day, and this is the demand probability distribution when it is a poor day. So let's look at the number to see whether it makes sense or not. So if it is a good day, you see that the highest probability, 35% here, okay, will be around 80 days. So very high percent that the customer will buy a lot. Okay, so it's around 70, 80, 90 days. The peak is around 80 papers. If it is a poor day, so where the poor day, you see the majority is here, 44%. The demand is 40, and very small probability that the demand is higher than that. Okay, so it makes sense. And a fair day, 40% that the demand is around 60. Okay, so this is high, this is fair, and this is poor. So in our simulation table, we will again assign a random digit, this one. All right, to generate the demand depends on the day. And we also assign random digit to decide whether this is a good day, fair day, or poor day, corresponding to this probability. So again, we will try to find out what is the number of newspaper we should buy, what is the inventory level we should stock. All right. So in this case, let's say we will calculate directly the cost. So we will calculate the profit. Okay. So we will try the certain number of newspaper that we buy. Okay, and then we will see how much profit we can get from that. So we need to calculate, we need to know the sales, the demand, and then we will, and with the paper we purchase, we will see how much revenue we get. Okay, what is the cost of the newspaper that we buy? What is the gross profit if if the demand exceeds the number of newspaper we have? And let's say if we buy too much. All right, so we keep the old newspaper. No one want to buy except we sell it as scrap paper. Right, we got some waste money. Okay, but we still lost the money and get back a little amount. So we get the salvage from the sale of scrap paper. Okay, so this is the way we calculate the profit, and we want to increase the profit. We want to vary different amount of the number of newspaper and see the profit we get. Okay, so all right, so again, simulation doesn't give us an answer, so we have to try with some number. So let's say we will try, we will purchase 70 newspaper and see what happens. Okay, we will purchase 70 newspaper. So again, we will decide to simulate for 20 days. Okay, now we start with day 1. We need to know if it's a poor or fair or good day, so we generate a random digit for the type of news day, and we get it is a poor day. So it is a poor day, we go to the random digit assignment for newspaper demand, look for the poor day. Okay, and then we generate another random digit to see what is the demand on that poor day. So we generate random digit and we get the demand is 60 for that poor day. All right, so we have certain information here. We will have like the paper seller buys the paper for 33 cents. It's newspaper. The cost to purchase one newspaper is 33 cents. Then we sell it for 50 cents. Okay, and then if we cannot sell it, okay, then we can sell his extra paper for 17 cents. All right, and then the newspaper can purchase in bundle of 10. Okay, whatever. All right, so these are the numbers that help us to calculate the profit. Okay, we buy for 33 cents, we sell the customer for 50 cents. If is if the day is over, then we only sell for sandwich with 17 cents. Okay, all right. So we say we decide to buy 70 newspapers. So we will calculate what is the cost of buying 70 newspapers. But the demand on that day is only 60. All right, so we will get some sandwich here on that day, right? The sandwich on that day, we still left with 10 papers, so we will calculate the sandwich from sale of 10 scrap paper here. Okay, and the revenue we get from the sale. So we can calculate the revenue for the first day is $30. Okay, and if we minus all the cost, we will get the profit for that day is $7.4. All right, so doing the same thing like that one, we got day 2. And it happened on day 2 is a fair day. Demand on that day is 50 days. Okay, again, we already decided to buy 17 newspaper and the demand is 50. So again, we still have the set of 20 papers, right? Okay, that's a lot more compared to today one. And our daily profit on that day is only $2.9. All right, so we try that for 20 days with the purchase of 17 newspaper and see how. Okay, and this is our profit, the sum of our profit for 20 days. We get $174.90 in total for 20 days. So can we increase this profit or not? Well, we don't know. We have to try, okay? So you may try to reduce this one to 60 to see how. Okay, because you see like many days we observe sandwich a few days, right? So you may try to reduce to 60. All right, or to 50, it's up to you, but we have to try. Okay, so this is another example of how we simulating a random event like a demand in an inventory system and to come up with a better inventory policy. Okay, All right, so is there any questions so far? If not, then we take a break, okay, and then we will continue with the last example of reliability problem in the factory. Okay. All right. So now is my clock is 2:20. So I think we can see again at 2:40. Are you there? Hello, class. Shall we continue? Hello. Okay. I'm sharing with you the slides. Uh, you're supposed to see slide 33 now. Can you see the slide? Okay, there's some left in. Okay, here it is. Okay, this is our last example of a reliability problem. So this is also a very common problem in production. So, well, in a factory, in order to assure the production goes smoothly, you have to do a good maintenance job. So, if you learn about lean production, you see that there are different ways, different types of maintenance. Okay, the one you can consider like firefighting is the one where we only wait something really serious happen like a breakdown event, then we go and fix it. That is not good. Okay, so a better one is a preventive maintenance. Okay, means we try to go ahead, like we will take care of the machine and replace the part before it's down, right? Because the breakdown events is actually very costly for factory. Okay, so the problem is we don't know the exact time, the exact lifetime of the part in the machine. Okay, so when you do the maintenance job, if you are in the maintenance team, you have to come up with a maintenance schedule. Okay, it's like for that machine, when you should replace the part in that machine. If you decide it's too short, it will be costly, but if you decide it's too long, then it may be too late. Okay, you may come up with an average lifetime of the part, but it's random. Okay, so that's a very common issue in the reliability problem. Okay. And then when you replace it with the part or when you do the maintenance job, the time to carry out it is actually also random. Sometimes it because you have to arrange people, you have to make a call for the service. Okay, and sometimes it takes longer than you expect. So you have to consider that random factor as well. So simulation is actually a good tool to simulate the reliability problem because it can deal with that randomness. So in this example, we look at a case, okay, where the engineers have to consider how to when we need to replace a bearing in a milling machine. You know the bearing, right? You know bearing. So usually in any machines, let's move out here. Oh, okay. Okay. Uh, thanks, Phương. Uh, wow, you thanks for a quick answer. Okay, so it's also come in the shape like this one. Let's say you have two parts like this one, right? And it's come together like this one. So in order to make it really fit, you also need a bearing inside here to make it really fit. The two parts really fit to each other. Okay, that's the bearing. And so that's one is quite is required replacing quite frequently. Okay, so we look at the information of this problem. The lifetime of the bearing is random. Okay, and the delay time of the repair person is also random. So when we need to replace the bearing, when it fails, we have to call the repair person, and there's a delay time, which is random. Now we have certain information related to the cost of the downtime. So when we do the replacing, we have to stop the machine, so it's considered downtime. So the cost for the downtime is estimated about $5 per minute. Okay, now we have to pay for the repair person. Okay, so he come, he fix it, and we have to pay him $15 per hour. Now, the downtime is $5 per minute, so we wonder how long it takes to replace. So this is the time information. It takes 20 minutes to change one bearing, 30 minutes to change two bearings, and 40 minutes to change three bearings. It means that in this machine, in this milling machine, there are three bearings inside. Okay, so let's say if you only have to change one, it takes you 20 minutes. If you have if you change two bearings at the same time, it doesn't take you 40 minutes, but only 30 minutes because you only need to open the machine one time. Okay, and again, if you change three bearings at the same time, it takes only 40 minutes instead of 20 multiplied by 3, 60 minutes because you only have to open the machine for one time. Okay. All right. Another cost when you replace the bearing, it costs $16 each. Okay. So this is a situation. We have two options. So one option is we wait whenever one bearing is failed. Then we will call the repairman and then we will replace only the failed one. That's common sense, right? But um, the engineering observe and see that usually the lifetime of the bearings are more or less the same. So when we see one bearing fail, it's very likely that the other two also fail sooner or later. So he thinks instead of waiting the other two bearings fail and then call the repairman, and then again it takes time for waiting him come, and then every time opening the machine, like it will take more time than, like if you open the machine 3 times to replace the bearing 3 times, it will take you 20 multiplied by 3, 60 minutes. Okay, but if you open the machine 1 time and at that time replace all 3 bearings, it costs you only 40 minutes. So he's thinking of maybe uh, when one bearing fails, perhaps we should replace all the 3 bearings. Okay, if we save time, of course we have to cost for the bearings, for the new bearings, because the other two doesn't fail yet, but we replace a completely new one. So we have to suffer that cost. But we have to judge whether it will benefit us more or not. Okay, so whether this proposal is good or not depends a lot on the lifetime of the bearing because it's random. Okay, so the engineer expect or doubt that they are more or less the same and replacing all 3 at the same time, you say. So we can test that proposal by simulation. Okay, so we will simulate the randomness of the lifetime, the bearing, and the delay time with 2 policies. The first policy, we will replace only the bearing which one is failed. Okay, and the second policy, we will replace all 3 bearings whenever a bearing fails. You get it? Okay, so let's start. Now, these are the information related to the bearing life distribution and the delay time distribution. Okay, so again, from our historical data, we record the bearing life. Okay, it varies from 1,000 hours to 1,900 hours. Well, it's vary a lot, right? Okay, and with different probability. So 10% out of all the bearing that we observe has the life 1,000 hours. Okay, let's say look at this one. 12% of the bearings that we observe have the bearing life 1,500 hours. And continue like this one. We will use the random digit assignment to simulate this probability distribution of the bearing life. Okay, you fill up this one. Now this is the delay time distribution. The delay time may vary from 5 minutes, 10 minutes, and 15 minutes with this probability. Most of the time, 60% of the case will take 5 minutes, but 10% of the cases take 10 minutes, and 10% of the cases take 15 minutes. All right, so now we will simulate for the first policy, and we will compare the cost of this policy with the second policy. Remember the cost you have to pay, the cost for downtime, the cost for paying the repairman, and the cost for replacing the new one, the new bearing. Okay, so this table gives us the bearing replacement simulation for the current method. Okay, so we have to monitor all 3 bearings at the same time. Now, we have bearing 1, bearing 2, and bearing 3. Okay, so all right, another thing is all right, so let's try number one. Okay, yeah. Number one, we will simulate the lifetime of bearing number one. Okay, we got a random digit 67. So the life hours is 1,400 hours. Okay, we will record the time of the simulation by looking at the accumulated life. Yeah. Okay, this is the simulation time. So okay, so it means that the first bearing will die after 1,400 hours, and then we have to call the repairman. So we call the repairman by generate a random digit. We got a random delay 5 minutes. Okay, all right. So it is now after we replace the new one. Okay, we monitor the second bearing number one, and the lifetime of bearing number one is 1,000. Okay, after 1,000 hours, it means that now our simulation time would be in total 2,400 hours. Okay, after two bearings, uh, it failed, so we call for service, and it had 5 more minutes to replace the second bearing one. Okay, so we do like that, and we will start our simulation at about 20,500 hours. We will start our simulation at around 20,000 hours. Okay, now we look at the bearing 2 also in this period. Bearing 2, the lifetime of bearing 2 of the first bearing 2 is 1,500 hours. Okay, we also record the simulation time here. Okay, and after 1,500 numbers, it fell, and we call for service. It had 15 minutes this time. Okay, then we have the new bearing 2. The new bearing 2 lasts for 1,200 hours, then fail, and then we call for service. It had 10 minutes. Okay, so we continue like that one, and we stop also around 21,000 hours, similar to the first bearing one. Okay, and for all the two cases, we will have the delay time. For bearing number one, during the 21,000 hours, we will have in total 16 bearing. With the total delay time, we will take the sum of the delay time here to replace bearing one is 110 minutes. Alright, for replacing 16 bearing one in about 21,000 hours. For bearing two, also in that period, we also have to replace around 16 bearings, and the total delay time for changing bearing 2 will be 125 minutes. Okay, and we do the same for bearing 3. Okay, bearing 3 we stop also around 21,000 hours. For bearing 3, we only have to replace 14. Right, 14 bearing 3, and this is the delay time for changing bearing 3. So with this statistic, we can calculate the cost for this policy. Okay, so we calculate how many bearings we have to replace in total. So the bearing 1 we replace 16, bearing 2 we replace 16, and bearing 3 we replace 14. So in total we have to replace 46 bearings, and each bearing costs us $16. So this is the cost for bearing, and we take the sum of the delay time for replacing 3 bearings and then the cost for delay time. Then we calculate the cost of downtime during repair. During repair, we cannot run the machine, so we have the cost for that downtime. Okay, we calculate the cost to pay for the repair person. Okay, it also depending on time, and come up. This is the total cost, around $7,000. Okay, so now we will try for the second policy where we replace all the 3 bearings as long as one fails. Now, in order to make it very comparable with the first one, we will try to simulate. We will use the same information of the lifetime like the first one. Right? So it means that we won't generate random digit for the second case, but we use the exactly lifetime of the bearing as we already generated for the first policy. Okay, for example, bearing number 1, the lifetime is 1,400 hours, bearing 2, 1,500. Okay, you look at this number, it will be the same with the one we generate here. All right, to make the two policy very comparable. Right, so we use the same number here. We don't need to generate the new random digit for the second policy. Okay, now let's look at this one. Number 1, bearing 1 life hours is 1,400. Bearing 2 lifetime is 1,500. And bearing 3 lifetime is 1,500. So which one fell first? Bearing number 1 fell first, right? Okay. So bearing number 1 have the least lifetime. So this one will fail first. The first failure will occur at 1,400 hours. Okay, and so we will call for the service. We generate a random delay. We got delay time 5 minutes. Okay, and they come and they will replace all 3 bearings at the same time. So we will have the new bearing 1, new bearing 2, and new bearing 3 at the same time. It's the second case here. Okay, so for the second one, we use bearing 1 life 1,000 hours, bearing 2 1,200, and bearing 3 1,400. So again, bearing 1 fell again at 1,000 hours. Okay, here we get the accumulated life to monitor the simulation time. We also start the simulation around 21,000 hours. Okay, so bearing 1 fell again, we call for the service. It takes 10 minutes delay to replace all the 3 bearings. Okay, now one more time, and then we can go to the conclusion. Let's try. It seems that in this simulation we see that bearing 1 always fell first. Let's look at the case. Okay, let's look at case 8. Bearing 1 is 1,400 hours. Bearing 2 life 1,300 hours. Bearing 3 life 1,700 hours. So in this case, bearing 2 fell first. Okay, it fell first. This is the first failure. So we call for service, replace all 3 bearings, take us 10 minutes. Alright, so we stop a simulation around 21,000 hours and we calculate the sum delay time for changing this method. Okay, so again, we will look at the cost for the new policy. Okay, so of course, for the second policy, we will have to replace more bearings compared to the first one, right? Can you calculate how many bearings we have to replace for the second policy? Okay, you see, every time like this one, we have to replace all 3. Okay, so we can count how many bearings we replace on in the 18 circumstance. Right, so it will take us about 54 bearings in total. Compare for the first case, we only have to replace 46 bearings. Okay, you remember the first one, the first policy, we only had 46 bearings. But the second case, the second policy, we have to replace 54 bearings. Okay, so it costs more in terms of changing the new bearings. But the delay time, we save a lot on the delay time. The cost of the delay time now only 125 minutes. Okay, and so it's also reduce the cost of downtime during repair. The number of time we call the repair person also less. So the cost in total for the second policy is around $5,000 compared to the $7,000 for the first policy. Okay, so of course, so if you do the simulation like this one, then you are very convinced with the second policy. All right, convinced, and you will be more confident to implement the second policy. You already evaluate the situation. Okay, so this is a great advantage of simulation if you already have certain solution in mind and you want to test it. Okay, so we already finished on the 3 examples related to simulation. Okay, so my objective is to introduce to you different areas of application, the common application, so that we have certain motivation for the rest of the course. Okay, so in the simulation, we see how we should determine the characteristic of the input data. Okay, we see one way of generating random variables. Okay, and then how we analyze the simulation results. How should we look at different statistics? Everything, the results random. We look at the statistic like the average one. Okay. But if you look at these examples, you may come up with many more questions to answer. Alright, so like in the examples I gave you, alright, the distribution of the random variables like the arrival time or the service time is in a very simple way. Like we have a fixed probability for a specific value, right? Right, we have a table of probability distribution. and I give you a way to simulate that. But let's say, how about if the random event or the random variable doesn't take up the probability like that, then how should you simulate it? Right? Right. It's not always that we come up with a probability, a nice probability distribution table like that. There will be more cases. So how would we deal with that one? All right. So we will learn that in another lesson. Okay. And then the simulations example that we try is simple enough for us to try by hand or using Excel. But if we have a much more complicated situation or system, right, how should we translate the conceptual model into the computer one? Okay, so what is the principle for us to translate the conceptual one? What is the methodology in simulation in general for more complicated case? Okay, so that's one we will learn in the next lesson. Okay, we will learn more on the more on the method that people use programming language to simulate a system in general, and the way people use a simulation software. Okay, how they construct their thinking in putting it into a programming using a programming language or using a simulation software. All right. Let's say in the example, you see that we have to decide when we should stop the simulation, right? So there's a sample, we will stop the simulation for 20 customer, or like in the reliability examples, we decide to simulate it for 21,000 hours. Okay, but you see that if we decide to simulate for 10 customers, it will be very different to simulate 100 customers. Or we simulate 21,000 hours would be very different if we simulate it for 2,000 hours. Right? The result would be different. When you take the average, will be different. So what is an appropriate number that we can be confident with our simulation results? Okay. So remember those questions and see how we will answer the questions in other lessons. Okay? All right. So that will bring us to the end of our lesson today. Um, I already posted the pre-lab slide and the exercise for you to do before the lab session next week, right? So you know that this one for simulation is a skill. Besides of the theory knowledge that we learn, the skill is very important. Okay, so the time that we spend on lab is certainly not enough. So we try to give you homework related to lab. Okay, and whatever simple enough for you to learn at home, then I suggest you to self-study at home. Right. So the first lesson I think is quite simple enough for you to self-study. So you need to complete that one before we start the first lab. Okay. So in the first lab, then when we will meet in person, we will continue from that. Okay, we will not go back to the basic one, right? And if you already tried at home, you can go to the class and come up with more questions. Okay, then we can utilize our time better. Right, so is there anyone have the problem in installing the software? Or let's say you have any problem in understanding the slides? If you have any questions, don't you have problem in installing the software? There are so many files. Okay, you have to go to. All right, like this one. Now for the current time, actually you can go to the official website of Arena and you download the student version first. Okay, so the student version is quite simple. There's no rack, so you can download directly from the website. That's the most simple one. Until we meet at last, okay, and then we give you more detailed instruction on lab how to install it. That's one option. Another option is you can go to YouTube. Just type in YouTube like how to install Arena 14 rack version. Okay, and it will instruct you for the steps. All right. Another point is that Arena is strictly for Windows. Okay, we cannot install in Mac unless that your MacBook is very strong. Okay, and then you can run the second Windows. You have an application that run another operating system is Windows, but that will make your laptop very weak. So this software is strictly for Windows, not for MacBook. Yeah, if you use MacBook, you have to use a virtual box, right? But it makes your computer very weak. Ok, cô nói tiếng Việt ha. Nó không có file riêng cho MacBook thì cô cũng sử dụng MacBook nào mà cô cũng cô có thử là ví dụ mình cài một cái virtual box mà để cho MacBook để run những cái application của Windows, nhưng mà khi mà cô cài vô đó thì cái máy của cô nó rất là yếu, nó cũng nó không chạy được, cái chạy chậm quá, thành ra là rốt cuộc cũng không chạy được. Thành ra là cho cái course này, nếu mà tụi em không kiếm được cái máy Windows nào dởm, ví dụ như là cô xài một cái máy Windows khác mà từ hồi năm 2006 07 á, cô mua hồi năm 2006 07 gì đó, thì cô vẫn chạy được Arena. Thì nếu mà tụi em có một cái máy tính nào dởm của Windows là cũng chạy được. Còn nếu không thì mình phải dành thời gian ở trên trường, mình phải vào phòng lab để xài máy tính ở trên trường. Chứ còn hoặc là MacBook của mình phải rất là mạnh để chạy song song một cái hệ điều hành Windows trên đó nữa. Nó giống như là cái virtual box thôi. Rồi thì nó có một cái bất lợi đó. Thì hầu hết các chương trình của engineering thì họ toàn là thiết kế cho Windows không. Nếu mà tụi em không cài được cái bản rắc mà cô gửi á, nó nhìn nó rất phức tạp quá, thì tạm thời tụi em có thể vào trang web của official của Arena đó, họ cho mình download bản student version thì mình xài đỡ cái đó, để đến khi nào mà vô lab thì sẽ có anh của Summer Lab sẽ hướng dẫn tụi em cài như thế nào nha. Rồi, rồi để mà không có câu hỏi gì thì mình ngưng tại đây ha tụi em ha. Rồi, sẽ gặp nhau vào tuần sau. Các bạn hỏi là extend the deadline for pre-lab homework. Lớp của tụi em là lab vào thứ mấy ha? Không có cái lịch ở đây, tụi em có nhớ lab của tụi em là thứ mấy không? Chiều thứ tư mà mình có lớp thứ ba. Hiện giờ cô đang set cho tụi em là deadline là thứ rồi cô hiện giờ có set deadline cho tụi em là thứ sáu đúng không? Ok. Rồi. Rồi, như vậy ha. Cô sẽ extend deadline cho tụi em là đến thứ hai nha. Đến thứ hai là trước buổi thứ ba, vì cô muốn xem coi tụi em làm như thế nào để thứ ba khi mình gặp nhau trong lớp lý thuyết thì cô sẽ biết để feedback với tụi em. Còn lớp lab thì chắc là lớp lab của tụi em thì chắc là cô không đứng lớp mà sẽ có một bạn khác phụ trách lab của tụi em và hướng dẫn cho tụi em, nhưng mà tôi sẽ biết được tụi em gặp vấn đề nào khi mà tụi em làm bài tập thì cô có thể là feedback vào thứ ba thì là tôi sẽ extend deadline vào thứ hai nha, thứ hai tuần sau, trong hết cái thứ hai tuần sau. Rồi, ok. Rồi, tụi mình cái gì mình dừng ở đây ha tụi em ha. Tụi em cứ nộp đi, nếu mà nó có trễ sau thứ sáu thì cũng không sao hết, tôi sẽ không tính nhiều chỗ đó, tôi chỉ tính thứ hai thôi. Ok ha. Rồi, vậy hôm nay mình dừng tại đây ha tụi em ha. Rồi, chào các em.